Bismillahirrahmanirrahim. In part B, we will discuss MRP process. So just like in master production scheduling, we saw MPS grid, and there were certain standard components in an MPS grid. So just like that, we have an MRP grid, and this is the standard structure of an MRP grid. So we have gross requirements, schedule receipts, projected available, net requirements, plan order receipt, and planned order release. So as I have repeatedly mentioned that gross requirements for the end item come from the master production schedule. So for end item, these gross requirements come from MPS. But for sub-assemblies and components, these gross requirements come from planned order release of the parent. So these are two possibilities. Gross requirements for the end item come from the MPS, and gross requirement for the components and sub-assemblies come from planned order release, this last term. So planned order release of the parent or the higher level sub-assembly or component, as we saw in the bill of material. Schedule receipts are also called open orders. So these are there are two possibilities. If the component is being manufactured by the organization itself, so that is something like work in process, something that is being produced, but some production has been complete, some remains. So that is just like work in process. And in the case of purchasing, that is something that has been ordered but yet not delivered. So again, here we have two possibilities for schedule receipts or open orders. Something that was ordered for production or purchasing before the start of this planning horizon, but that has not been received yet, but that will be received somewhere over here. So for example, we ordered something for 100 units, and that will be received in period 2, so that is schedule receipts. Net requirements are the difference of gross requirements and schedule receipts and projected available balance. So for example, if we have gross requirements of say 500 in period 1, and we have say schedule receipts of 100 in period 1, and we have a projected available of 100 in period 0. So our net requirements will be actually 300. We need 500, but we already have 100. We have 100 items to be received. So the net requirements will be 300. And plan order release is the quantity that you will be ordering. So for example, if our lot size is 200, and let's suppose lead time is 2 weeks. So if we are ordering something, if we require something in week 4, so for example, we require 200 items in week 4, so we will be releasing order in week 2 so that we can receive those 200 in week 4. So this is something that I have done here. It's called lead time offsetting. So based on the requirement in week 4, I have placed the order in week 2. So this is planned order release, and this is planned order receipt. Another important point is that these scheduled receipts and planned order receipt and planned order release. According to MRP logic, all these are at the beginning of the period. So these three are at the beginning of the period. So for example, if I have a plan, if I have a scheduled receipt of 100, so that means I will receive 100 units at the start of week 2. Same is for planned order receipt of, say I have a planned order receipt of 200, so that will be at the start of week 4 in this case. And 200 here means order will be released at the start of week 2. Similarly, the projected available is at the end of the period. So similar to MPS. So if I have a projected available of 50 here, so that is the ending inventory that I will be having at the end of period 2. So receipts and planned order release are at the start of the period, and projected available is at the end of the period. So here it means that these 50 are actually the ending inventory for week 2 or the starting inventory for week 3. So to complete this matrix, we need to understand how to perform exploding and offsetting. So we discussed exploding in the previous segment. I have given you an idea of lead time offsetting. So based on the requirement in a certain period, we offset the lead time and place an order in an earlier period. So again, if we require 200 here and we have a lead time of 2 weeks, we place an order here. And again, we are not considering, in this case, safety lead time. But if we are considering safety lead time, of course, accordingly, we will place the order earlier than this. How to calculate gross and net requirements? I have given you an idea that gross requirements for the end item come from MPS, gross requirements for the components come from the planned order release of the parent, and you will see this in detail in the examples. And this concept of gross requirements, the net requirements, as I have mentioned, that this is gross requirements adjusted against scheduled receipts and projected available balance. So if there are no scheduled receipts, there is no previous inventory, then gross requirements will be equal to the net requirements. So we should also need to know how to calculate projected available and when to release orders. So these important questions need to be answered in order to complete this matrix. So we have answered few of them partially, and we will answer the rest of them in the following slides. So you are aware of what is lead time. It is the span of time needed to perform a process. For example, if B and C are available in this example, if we have B available, we have C available, then it will take 1 week to assemble A. Thus the lead time for A is 1 week. That is obvious. If D and E are available, these two end items, the time required to manufacture B is 2 weeks. So that is the basic idea. And again, we are not considering the downtime and eventually incorporating the safety lead time. We have already discussed exploding. Offsetting is the process of placing the exploded requirements in their proper periods based on lead time. Planned order release shows the latest. This is very important. This shows the latest when purchase or production should be started. So ignoring the safety lead time. It depends on the planned order received. So when a part is needed. So we can say that we are basically backward scheduling here. So we first see when a certain component will be required, and then we offset the lead time to release the order. So let's solve an example quickly. It is not showing the complete MRP matrix here. We are going to discuss the concept of lead time offsetting. So we have the end item A that has a lead time of 1 week that consists of B and C. These are the two sub-assemblies. The lead time of 2 weeks for B, 1 week for C, and B has two components D and E. Each of them has a lead time of 1 week. So simple example, again we need 100A at the start of week 6. So we will place order at the start of week 5. Similarly we need 50 A at the start of week 5. So we will place order at the start of week 4. Now B is the subassembly or component of A. So its gross requirements come from the planned order release of its parent, that is the part A. So these planned order release will become the gross requirements for B. So we need one B to make one A, so there will be no exploding required. So the lead time for B is 2 weeks. So in order to have 100 B at the start of week 5, we will place order at the start of week 3, and for these 50, we will place order at the start of week 2. C is also the component of A, so same gross requirements, this 100 and this 50. But the lead time for C is 1 week, so we will place order 1 week earlier. Now D is the component of B, so its requirements will come from its parent, that is B. So for D, we need this 150, so 150. So these are planned order receipts actually. So lead time is 1 week, so plan order release of 150 1 week earlier. And similarly, E is also the component of B, so plan order receipt of 150, lead time is 1 week, so plan order release of 150 1 week earlier. So that is the concept of lead time offsetting. So this was a simple example, and we didn't discuss the complete matrix in order to grasp the concept. Another important concept that we are going to discuss somewhere in between is the firm planned orders. So a planned order that can be frozen in quantity and time. So this is very similar to demand time fence. Conceptually, it is similar to a demand time fence that we discussed in MPS. The computer is not allowed to change the planned order in terms of quantity and time automatically. So this is the responsibility of the planner in charge of the item that is being planned. So this may be in response to a known material or capacity issue. So we sort of lock the logic of MRP and we don't allow the MRP to execute its logic because we know some practical issues that are going to happen. So we plan orders, and based on some unforeseen you can say unforeseen problems that we didn't incorporate when we were making the initial MRP. So we revise the plan as needed and we make it firm planned order. So it is now up to the planner when to release the order or make some changes in the order. So sort of we have bypassed the logic of MRP. So that is called firm planned order. So how to calculate net requirements? So as we saw that net requirements are equal to gross requirements minus casual receipts if there are any, minus projected available inventory from the previous period. So we will see how to calculate net requirements. So we have seen this repeatedly, that the gross requirements of the parent come from MPS, and planned order release of the parent becomes the gross requirement of the company. So let's solve another example, and again this is not the complete MRP matrix. So we have this again same product tree. So the product tree is the same, but we have 20 A's available in stock, as well as we have 10 B's available in stock. 50 A's are required in week 5. So 20 A's are available, 50 are required at the beginning of week 5, and 10 B's are available. And order policy or lot sizing policy is lot for lot. So there is no gross requirement up till week 5. So this inventory of 20 will be carried up till week 4. In week 5, we have net requirements of 30. So plan order receipt is 30. Lead time is 1 week. So plan order release will be equal to 30. So B is the component of A, as you can see from here. So this plan order release of 30 will become the gross requirements for B. So this inventory of 10 will be carried up till week 3. So the net requirements will become 20. So plan order receipts will be 20. So accordingly, the lead time for B here you can see is 2 weeks. So plan order release will be in week 2. For C, now C is the component of A, so we will have this 30 to be the gross requirements. There is no scheduled receipt, so this 30 will be the net requirement. This 30 will be the plan order receipts. Lead time for C is 1 week, so plan order release of 30 1 week prior. Now D is the component of B. So this 20 will be the gross requirements, no scheduled receipts. So same 20 will be the net requirements. Plan order receipt of 20. Lead time for D is 1 week. So plan order release of 20 in week 1. E is also component of B. So same 20 will be the gross requirement in week 2, no scheduled receipts. So net requirements will be 20. Plan order receipt of 20. Lead time is 1 week. So plan order release of 20 at the beginning of week 1. So that is the concept of offsetting. And again, we are still not considering the concept of exploding, but in one of the following examples, we will see it. So without considering the safety lead time, this is how we can offset the lead time. Let's solve yet another example, a relatively short example. So here we are given the gross requirement for certain item with a lead time of 2 weeks. And here the order quantity is not lot for lot. It is a fixed order quantity, and that is 100 units. So we have 75 items already in inventory. There are no gross requirements in week 1. So this inventory of 75 will be carried on in week 1. So we have 75 items available. There are gross requirements of 50. So after meeting these requirements, the ending inventory at the end of period 2 will be 25. Now we have 25 available. Gross requirements are 45. So our net requirements is gross requirements minus projected available minus scheduled receipts. So 45 is the gross requirements, no scheduled receipts minus projected inventory of 25. So the net requirements will be 20 in week 3. So we need a scheduled receipt here as per the lot size, that is 100. Lead time is 2 weeks. So we have to place order at the beginning of week 1. So 20 in inventory plus 100 plan order receipt 125 minus requirements of 45. So 100 plus 25 minus 45 will be 80. So we will have an ending inventory of 80. So we have 80 inventory, the gross requirement of 20. So after meeting these requirements, we have projected available of 60 at the end of period 4. One important point that you should keep in mind is that in all these examples that we have discussed so far, we have not considered both safety lead time as well as safety stock. But if we focus on safety stock at the moment, then the logic of this matrix will remain the same. But here we were focusing on the net requirements based on zero ending inventory. But when we have a certain safety stock, then the reference will become the safety stock. So our ending inventory should not be less than that safety stock. So we will discuss that point in one of the following examples. So that is the solution. So in the next segment, we will discuss the complete MRP matrix using the same concepts. Just one thing was missing in this matrix, and that was the schedule receipts. The rest of the 5 terms are already there. We will also see the schedule receipts in the complete matrix, as well as in one of the examples, we will see the safety stock as well. So net requirements then will become gross requirements minus schedule receipts minus projected available. So far we were not considering schedule receipts. Thank you.